Hi everyone, welcome to the Spatial Data Science MOOC. I'm Lauren Bennett, Product Engineering Lead for the Spatial Analysis Development Team here at Esri, where I lead research and development of our spatial data science capabilities across ArcGIS.
And I'm Shannon Kaliski. I'm the lead product manager for analytics and data science, where I work with geospatial professionals, data scientists, business analysts, really all of you, and our development teams to help shape the future of data science products.
And I'm Flora Vale. I'm a product engineer on the spatial analysis team where I focus on data visualization and spatial analysis throughout the platform. And we are really excited to kick off the MOOC and give you a guided tour of all things spatial data science within ArcGIS.
We're going to be unpacking the black box of some of the most widely used spatial data science techniques. Each week, we'll pick a topic, explain how it works, and then you get the chance to try it out for yourself.
Okay, first things first. What is spatial data science exactly?
Tough one.
It's a good question. It's a tough one. I would say that if we asked 10 people, we would probably get 10 different answers.
Without a doubt, yes.
But it is worthwhile for us to reach some sort of consensus because we can use that as a framework for the next few weeks. So I think that spatial data science fundamentally is about solving problems. It's using spatial algorithms, the latest and greatest techniques in machine learning and statistics and deep learning, as well as some of those tried and true, more traditional techniques to turn our data into useful, actionable information. So what about you, Shannon? What do you think?
Well, I think it's a really exciting time to be involved in spatial data science. I mean, on the one hand, we have geographers, geologists, and researchers and analysts from a wide variety of other fields who've been using location as an essential part of their analysis for decades. And now we're seeing more and more data scientists with backgrounds in computer science and statistics and programming just starting to wrap their minds around how to use location to build better models. So for me, spatial data science is really that place where those two worlds intersect.
And I think an important differentiator of spatial data science is that we're not just using traditional methods and applying them to data that happens to be spatial. We're using techniques that incorporate spatial characteristics or some element of location directly into the mathematics of the algorithm. Things like shape, area, size, direction, and proximity play a key role.
Now, we get asked a lot, what's the difference between data science and spatial data science? And I think in a lot of ways, there really isn't a difference. We're building on those traditional techniques and adding that critical element of space.
It builds off what's called the first law of geography, which is that things that are closer together are more related than things that are farther apart. It seems simple, but it's critical, and it's why the spatial in spatial data science is so important.
So I think we'd all agree that spatial data science builds on these foundational data science techniques and adds that element of location that really makes a huge impact on the outcomes of our analysis. Now, the spatial data science process encompasses data visualization and exploration, data and feature engineering, the application of analysis and spatial analysis techniques, and the sharing of those workflows and results.
But this process isn't linear, as I'm sure you know.
No, it's not.
It's an iterative process. You try, you fail, you try again. You may compare different algorithms and methods to see which one works best. You go back to the drawing board a few times. It's all part of the process.
And each week, you're going to see this process come to life. We're going to explore prediction, clustering, spatiotemporal clustering, suitability modeling, and deep learning, some of the most powerful spatial data science techniques.
And we're going to go a lot further than just how to click the button or run the script. We're going to really dig into how these methods work, how to interpret the results, and how to use them to solve problems. That way, at the end, you'll be ready to hit the ground running.